Kumar, Associate Professor from HBTU. He will be delivering expert talk on open and winding induction motor drives for electric vehicle applications. We are really glad to have Dr. Sanjeev sir with us. He is having a vast experience in the field of open and winding induction motor drives and power electronics domain. So I'd like to thank sir for joining us on behalf of Department of Electrical Engineering and all the course coordinators. I welcome you, sir. Thank you, sir, for your time. This call is now being recorded. For introduction, I would like to call the
Yes, sir. Good afternoon, participants. Now I'd like to introduce Dr. Sanjeev Kumar, sir, our next session tutor. He is currently working as an associate professor in the electrical engineering department of Harcourt Butler Technical University, which is famously known as HBTU University, Kanpur. He completed his MTech and PhD from the Indian Institute of Technology, Roorkee, famously known as IIT Roorkee. Apart from teaching, he also worked as numerous positions in the college. Particularly, he worked as Associate Dean, School of Engineering from 2022 August onwards. Also, he worked as Associate Dean, Academic Affairs Officer in charge of SPS, University Faculty in charge in placement, Dean of School Nominee and DPC of University, Dean Academic Affairs Office. His research area mainly focus on multi-level inverters, open and winding induction motor drive, high power converters, power electronics, industrial electric drives, microprocessor control electric drives, and active power filters. Today he is going to give a lecture on open and winding induction motor drive for electric vehicle application. And now I am requesting Dr. Sanjeev Kumar sir to begin the session.
Thank you, Sukant, for giving such a wonderful introduction of mine. Today I come to know I did so many jobs. Anyway, as the topic of the STC is Power and Control Strategy for Non-Zero Emission PCSC 2023. Nowadays, everybody is talking about the reducing the carbon footprint, right? And this particular in this category, the electric vehicle can contribute a lot. So that my today's lecture is related to your the motor. That the purpose of motor is to drive that particular electric vehicle. On that, I'll focus in today's lecture. And the topic is open and winding induction motor drive for electric vehicle. As we all know, the basic structure of any electric vehicle is like there is electrical motor oblique generator. I'll explain why I have written this motor oblique generator, because whenever we do the regenerative braking, then that machine is used as a generator, and while driving the vehicle we use as motor. So we have first of all that this infrastructure for charging, which will charge your electric battery. Once that battery is charged, then it is go to the your this drive particular converter, that is DC converter if we are using, because this today's everybody is talking about renewable energy, electric vehicle, and so many things are included in the distributed system. So there are several configuration of electric vehicle as well. It is vehicle to grid or grid to vehicle, vehicle to home or home to vehicle, something like that. So as you can see, we have charger. From charger we charge this battery, right? Then we have this DC converter system for leveling purpose. right? Once we have DC-DC converter that is used for, suppose we have 12 volt and we require 220 volt, and for that purpose this DC-DC converter is there. Then we have inverter system which is used to convert this DC into AC so that our electrical motor can run. And you can notice that let me change the, just a minute, let me change the color of this ink. Okay, now you can see this is bidirectionally, means power can flow from motor side to AC side like this, or from AC side to motor side, right? For that purpose all links are bidirectional. You can see all are bidirectional, right? So the basic component of this entire electric vehicle is electric engine, which is of course battery driven motor based system, then battery, then for motor controller we have some sort of controller, and if we operate in regenerating mode, then there must be some system which is operated in this regenerative braking mode. I hope different other experts have taken some of these talk, and today's I'll mainly focus on your motor, right? So in motor, if we use induction motor, right? Simple induction motor, and if we operate it in using the simple inverter, right? Simple two level inverter, then you know the TSD of the output voltage is quite high. Then at the TSD, if the TSD is high, there are so many other problems like each device will suffer for high dV dt, right? There is also problem of common mode voltage problem, right? To overcome all this, we go for this open and winding based induction motor drive. It's very simple drive, right? Don't think it is very complicated in short of its configuration and all. The same induction motor can be used as open and winding induction motor. What we have to do, we have to just open its neutral point. Suppose we have A1, A2, B1, B2, C1, C2. In general, these terminals are short, so we fed these terminals by inverter, and this inverter is supplied by DC. Right? This is the general configuration. But in open and winding based induction motor, what we have to do, we just remove this. Now this terminal is open, so we have total six terminal, right? A1 B1 C1 and A2 B2 C2, and these six terminals are fed by simple two level inverters. Both side of the terminal stator winding is open. Now we have six terminal, and these six terminal are fed by two two level inverter, right? One from this one side and another from another side. And one thing you should also notice that the input is half of the total DC link voltage. Suppose here we required VDC as input voltage when we fed our induction motor by two level inverter, then this configuration we required two isolated voltage source. We required two isolated voltage source of amplitude VDC by 2. Is it okay? Right? And I also request to all participants, if you have any doubt or any query, please ask. I don't want to make this lecture monotonous, like I keep on talking for 1.5 hours. And at the end of the talk, just thank you, and it's okay. No, if you have any doubt, anything you want to ask, you can ask, right? So the dual level inverter configuration is like this. We have VDC by 2, VDC by 2, two isolated DC source which are feeding the two level inverter. The advantage of this type of configuration is we get output voltage correspond to three level inverter. Those researcher or faculties who are working in the field of multi-level inverter, they know very well. We always want sinusoidal supply to operate an induction motor, but it is very difficult to have sinusoidal supply. We can obtain almost sinusoidal by increasing the switching frequency. If we increase the switching frequency, then what happens? Switching losses increases. Our efficiency of the inverter is decreasing. So we go for multi-level inverter operation. Ideally speaking, if we required this pure sinusoidal wave, then we have to have infinite number of levels, right? But that is very difficult because number of switches are increases drastically. In so it is very difficult to manage all those switches, and the reliability issues are there, and so many things are there. So we have to have compromise between the number of level and the quality of the output, right? So if we talking about this particular inverter, you can see this is very simple inverter. We have two level inverter. This is one two level inverter one, and this is two level inverter 2, and fed by this VDC by 2 supply. Right, this it is VDC by 2. This is also VDC by 2. Right. This actually it is written in the math type. So taking in the PowerPoint presentation, some this displacement of this alphabet and the line is there. So it is VDC by 2, and another one battery is also VDC by 2. Now the voltage, if we talking about the pole voltage means VA1O, VA1O, right? It would have two level. It can be VDC by 2 if S11 switches on. It can be S1, it can be 0 if S14 is on. Right? So we have either 0 pole voltage or VDC by 2. Similarly, inverter 2 can have VDC by 2 or 0. So motor phase voltage, that is VA10 minus VA20 dash, if you calculate, it would have three level: minus VDC by 2, 0, and VDC by 2. Right? So, and it is obtained by this, which I have already explained you. When S4 is on, this voltage is 0, VDC by 2, and S21 is on, so inverter 2 voltage is 0, so net voltage is like this. Just see here. When S14 is on, the voltage is 0. This is like this. And when S21 is on, the voltage is VDC by 2. So 0 minus VDC by 2 is come out to be VDC by 2 with minus sign, right? Very simple thing. So we have three levels: L1, L2, L3, correspond to motor phase voltage minus VDC by 2, 0, and VDC by 2. Right? And this is the mathematical modeling of well two level inverter. I would appreciate if someone tell me if he or she is working in this particular field. Any participant who is working on this multi-level inverter or this open and winding based configuration? If we have, okay, no problem. Uh, anyway, so though actually in MATLAB this open and winding based induction motor is not available. However, in latest version, it might be maybe in 2021 MATLAB, this may be included, but prior to that, it was not available. So, for modeling purpose, you can use this mathematical model, right? Where you can see the common mode voltage is this VA20, VB20, VC20 minus VA10 plus VB10 plus VCNO divided by 3. This is the common mode voltage. This is the common mode voltage. Right? But there is no chance of flowing common mode current. Reason is both sources are isolated. So there is no path for flowing this current. Now this space phasor is given by this, and if we bifurcate in DQ component, it is come out to be this in terms of motor phase voltage, in terms of motor phase voltage, right? So after doing modeling, we have to generate the pulses for triggering the switching devices. As we know, the number of level of multi-level inverter, for example, we have n level multi-level inverter, then we require n minus 1 triangular pulses, right? So this is the 3 level inverter, so we require 2 triangular pulses, right? And the entire region is divided in 3 region, which you can notice here. The first reason is this, means the reference sine wave is more than the first triangular, right? Reference sine wave is more than the first triangular. So this is the level 1. Now when reference sine wave is greater than the triangle 1 and less than the triangle 2, then it is level 2. And the third, when sine wave, reference wave, I should say reference wave, because it is the third harmonic injected wave, right? We try to get the space vector performance equivalent. There is one paper of Professor K. Gopakumar from ISC Bangalore. You can refer that one. To get that, we have a sine wave. Then we added maximum plus minimum of this sine wave. All 3 sine wave. Here you can see. The offset is added a maximum of 3 reference sine wave VA VB VC plus minimum of 3 reference sine wave VA VB VC divided by 2. This is added in the reference sine wave of particular phase. When you added this, you will get this type of reference wave. This type of reference wave, right? So it will give you performance equivalent to the space vector model, because you know this space vector to means, especially when number of level is more than 3, it is very difficult to means calculate the particular triangle and the particular sector and the position of reference phasor and all those, right? So we use this simple approach to get the performance equivalent to this space vector modulation, right? And this is the MATLAB model you can simulate at your end. We have two inverter and one open and winding induction motor, right? And the drive is operated in open loop at constant frequency VYF control. Why constant VYF? Because we want to have a constant flux operation. To have constant flux, your ratio of voltage to frequency must be constant. So irrespective of the speed, whether it is a low speed or the high speed, your VYF has to be constant so that your flux is constant. That logic is developed here, and the motor is drive is simulated, motor drive is simulated and operated at 1 kilohertz. You can notice the switching frequency is only 1 kilohertz, right? And it is operated at point 2, point 0.8 and 1 modulation. Of course, this one, because you cannot have more than 0.866 in case of space vector modulation. So this one correspond to the over modulation range. Over modulation means your multi-level inverter operation is no longer the multi-level operation. It is converted into simple two-level operation, right? So here are some simulation result. You can see at modulation index of zero point 0.2. At modulation index of zero point 0.2, you get simple two-level inversion operation, and these are the pole voltage. These are the pole voltage, and this is the phase voltage which you can uh, notice, right? When common mode voltage is added with this, you will get the phase voltage of motor like this, right? And this is the TSD of motor phase voltage and motor phase current. You can notice the highest order because the frequency correspond to 10 hertz, right? So for harmonic order 100 means all lower order harmonic, be it 20, 640, 60 up to 80. You can notice all third, fifth, seven, all order harmonics are very less, and the TSD is 132.53%, but the dominant order is order of 100. As you know, the dominant harmonics are far away from the fundamental. The filter design is simple and the small filter you require, right? It is difficult to eliminate the lower order harmony because the filter size is bulky, but as the harmonic order is quite high, a simple this small filters are required, right? And the current harmonic, you can see the current harmonic is that is on the next page. I think just a minute. Here, that this current harmonics is less than 5%. Less than 5%. Right? It is less than the 5%. Whereas the voltage harmonic, the dominant harmonics is more than 20%, and it, it is 132% just because of this, that the 200 order of harmonics is having amplitude more than 70, right? And it is the side band of 200, 200 plus 1, 200 minus 1, that is 199 and 201. Clear? Now this is the motor phase voltage for frequency for the modulation index of 0.8 at this 40 hertz, right? And you can notice that TSD is reduced from 132 to 32.18% here, right? Very much improvement, but not that much as expected, as required. So further we will go for higher number of level, and this is the voltage waveform. You can see for over modulation range, over modulation range, that the frequency is 50 hertz, modulation is 1. You can see the number of levels are missing. So some inverter is turned into simple this two-level inversion operation. Two-level inversion operation. That is why numbers of levels are missing, and it would have more third harmonic that you can see. Mhm. Here you can see the when it is at over modulation range, lower order harmonics are increased. Lower order harmonics are increased. Even fifth harmonics are there, seventh harmonics are there. Whereas when it is means under modulation, then harmonic order was 200, like that. And you can also notice that harmonic in current is also increased drastically. Now it is 14%. Use current harmonics are there, right? So we don't operate in over modulation range. And this is the transient operation. You can see this all of sudden this point 2 to point 8 modulation index is changed from point 2 to 8. You can see it is changed from 2 level to 3 level inversion operation, and voltage is changed immediately, whereas current takes certain cycles, some cycles, to come again stabilize. You can see the amplitude of current is almost same. Amplitude of current at no load is almost same, but the frequency, of course, it has to be changed, because at point 8 modulation the frequency is 40 hertz, whereas point 2 modulation frequency is less. And the same thing is happened in reverse order, means it is changed from point 8 to point 2, right? So current, there is some requirement of some cycle. After some cycle, the drive gets stabilized. So stability is not means the big deal. It is properly attaining its stable position within few cycles, and voltage level immediately changes. Right now, this is the comparison which I have already explained to you. Uh, these are the advantage of this type of configuration, that is dual two level, or the, you can say, the open and winding based induction motor drive. The advantages are no requirement of clamping diode or DC link capacitor, which is required in the neutral point clamp inverter, right? Here, for 3 level inversion operation, only 2 isolated DC supply are required, in comparison to 3 level cascade edge bridge, where you required 6 supply, right? 2 for each phase. Sorry, one for each phase. One for each phase. So 3 in comparison of 3, you required only 2, right? As compared to the flying capacitor, it does not require any flying capacitor, because we don't use any capacitor here, right? So these are the few example of few advantages of dual two level inverter supply. Now, extending the same, we go for 5 level inverter. You can see this portion is from previous one up to this, isn't it? Now we extend, or we, you can say, we add one more module of 2 level inverter to get 5 level inversion operation. Another thing you must notice, that the total DC link voltage, that is VDC by 4, this plus VDC by 2, this plus VDC by 4. So still you can see VDC by 2, and this VDC by 2 is VDC. So total is still VDC, right? You can, once I complete this topic, you can understand what is the advantage of this dual two level inverter operation, because in electric vehicle the major concern is how to minimize the size of battery, and how to this charging and discharging, and not discharging, of course its charging can be made the fast, right? So you can see we are using more and more module, more DC link batteries of a small size, and the total DC link voltage remains same, means the total power which is required to operate a motor that induction motor power depending upon the induction motor voltage rating requirement, that DC link voltage requirement is fixed, and that DC link voltage you can have a small size of battery, so that parallelly you can charge all batteries, so charging time can also be reduced, right? Anyway, that is another aspect of the lecture. Now come to the point. Here we have left hand side three level inverter. This is your three level inverter, right? And this is your two level inverter. Clear? So we can have five voltage level. The pole voltage of three level inverter could be 0, it could be VDC by 2, or it could be 3 VDC by 4. Let me explain this. You can see here, when this switch is on, the pole voltage would be 0. When these two switches are on, the voltage would be 2 VDC by 4, or you can say VDC by 2. And when this switch is on, you would have 3 VDC by 4. So 0, 2 VDC by 4 and 3 VDC by 4. It can have these three values: 0, 2 VDC by 4 and 3 VDC by 4. Similarly, the right hand side inverter could have 0 and VDC by 4 level. Now, motor phase voltage would be minus VDC by 4, 0 plus VDC by 4, 2 VDC by 4, 3 VDC by 4. 2 VDC by 4 means VDC by 2. Right? So, gradually, in the step of VDC by 4, level are increases. Right? And this is the switching combination. How to get this? Now, just a minute. This is the phasor diagram, and I am skipping this because of time constraint. And this is the formula, very important formula. How to decide the voltage rating of the battery. This is VDC by 2 VDC by N is equal to N2 minus 1 divided by N2 times N1 minus 1, where N1 and N2 are the number of level of the inverter. For example, this is 3 level, so N1 is 3 and this N2 is 2. So it is come out to be 2 minus 1, 2 times 3 minus 1. So it is 1 by 4. The ratio of VDC2 by VDC1 is equal to 1 by 4. Now add both sides. VDC1, add both side 1, add both side plus 1. So we will get VDC2 plus VDC1 divided by VDC1 is equal to 5 by 4. Right? So from here we will get VDC1 is equal to 4 by 5 VDC. Right? VDC1 is equal to 4 by 5 VDC, and we are using 2 batteries, so it is further divided by 2, so it is come out to be 2 VDC by 5. It is also 2 VDC by 5, and this is VDC by 5. Now you can notice the same configuration was used previously, where this battery was VDC by 4, this was VDC by 2, and this was VDC by 4, and we have a 5 level inversion operation. Now by simply changing the voltage level of the battery, we get 6 level inversion operation. Yes. you can see we can have minus VDC by 5, we can have 0, we can have plus VDC by 5, we can have 2 VDC by 5, we can have 3 VDC by 5, and we can have 4 VDC by 5. So 6 level inversion operation can be achieved by simply changing the level of the voltage, right? And the operation is evaluated simulation as well as in the hardware. For developing hardware, this open and winding induction motor, it is fed by two inverter A and inverter B. In the first case, inverter A and B both were the two level. Whereas for having 5 level, we can have inverter A as a 3 level inverter and inverter B as a 2 level inverter. Right? So we can have various configuration like this. Now these inverters are to be triggered. These inverters are to be triggered by some gate pulses. So how those gate pulses are generated? Those gate pulses are generated using Opel RT system. That is the real-time simulator. Those who are working in the power electronics field, they might heard about Opel RT or Typhoon Hill or D-Space, right? So all these real-time simulation, because see, previously we have to develop our control circuit using the analog devices. That was very difficult, right? But here now you can simply generate your control algorithm in MATLAB and simply convert in particular C code that the software is already available with the real-time simulation tool, and dump it in the real-time simulation and generate the pulses depending upon your uh, algorithm and the choice, right? So for that, what we do, we develop our MATLAB model on host PC, and that code is dumped in Opel RT system. It, it continuously measures the various parameters. Parameters means its motor voltage, current, speed, or whatever the parameter is required to develop your control logic. Then from there it will generate the pulses. It will generate the pulses for your IGBT, because I have used the IGBT as a switching device. Depending upon the power rating and switching criteria, you can have MOSFET, IGBT, or anything which you feel suitable for your particular application. Now these generate the pulses are fed to the device gate driver, but you can't do directly. It has to be isolated. So you must have isolation circuit. Isolation circuit is must required circuit. Why? Because that control and power circuit has to be isolated. Your Opel RT system is very costly. Your control DSP base or display base, these are the costly equipment. It has to be isolated from the power circuit of the inverter. So isolated circuit is there. Then we have dead band circuit. Why dead band circuit is required? Dead band circuit is required. You know, just a minute. If the same leg means, if you remember, there are two switches in a. I mean, each leg is having two switches. If they trigger at the same time, that means upper switch is going to be off and lower switch is going to be on. There may be situation the upper switch is not completely off and lower switches get on. So there would be that short circuit with the supply and huge amount of current flow through the switches, and your switch can be burned. To avoid that situation, that band circuit is provided. Right? Certain microsecond delay is there given to the upper and lower switches of the inverter. These are very simple things which I hope you all know. right? Then these fed these pulses are fed to the IGBT driver circuit. That because these are the 5 volt pulses, right? These are the plus 5 volt pulses, and your IGBT driver required 10 to 12 volt pulses. So that has to be boost. That level has to be boost using the some IGBT driver circuit, right? And then these pulses are fed to the inverter. These pulses are fed to the inverter, right? And motor is operated. These are the hardware, developed hardware in the lab. You can see we have voltage and current sensing circuit to obtain the various parameter which are required to develop control strategy. And this is the your host PC. These parameters, these voltage and current or speed is sensed and fed back to the this OpenRT system. And depending upon these voltage and current and actual speed and your control logic, it generates the pulses for your inverter. You can notice two pulses are generated, means one for inverter A, other for inverter B, and this is passed to the isolation and deadband circuit, and after that it is given to IGBT base inverter circuit, and those inverter give the supply to the open and winding induction motor. You can see these are 6 wires, right? Red color zones, these are the power circuits, right? So your open and in winding induction motors operate, and these parameters sense a continuous basis, right? And the results are obtained. It is uh, before showing the result. These are the photograph of current sensors, voltage sensor, and isolation deadband circuits, etc. Right? This is the experimental setup of this. Now this is the result. You can notice exactly the same result which we have obtained in our hard simulation, the same type of result we have obtained in our experimental validation, right? This is at the modulation index of 0.2, and the frequency is 10 hertz. So you can see this is the output voltage and this is the motor current, right? And these are the pole voltage. These are the pole voltage, right? These are the pole voltage. Now this is the TSD analysis. One can wonder ki see these results are look like simulated result. No, it is not simulated result. Although it is this figure is obtained in the MATLAB. How it is possible? See, in the OpenRT system we have analog input and analog output. Through analog input we sense the current and voltage, and once we have real time data with us we can save it in the MATLAB, and after saving that data we can derive this TSD and all from the workspace, which we exactly do in simulation. What we do in simulation? In simulation, we save the scope data with time structure, and we draw the FFT and all those things, right? Using Power GUI. And here you have to write code for these data to develop to have this FFT window and all, right? So these are the your hardware result, right? Another way of taking hardware result, you can use your fluke meter and all those things, but since the harmonic order is quite high, so these are not clearly visible in those meters. That is why you require the this data in workspace, and you have to derive this using MATLAB, right? Okay. and this is the motor phase voltage for 10 hertz in simulation, and these are the in hardware. Just for your reference, I have again included here, right? So you can see there is one-to-one analogy between simulation and hardware, right? And this is the motor phase voltage, right? For 5 level inversion operation at zero point 0.4 modulation index and 20 hertz, right? So you can see the TSD is reduced to 31.87 voltage TSD. I am talking about the voltage TSD, and if you see the current TSD, it is quite low. It is only 3.47%, right? And the dominant order harmonics are at 50 hertz, right? Dominant harmonics are at 50 hertz, right? So this is for modulation index 30. Modulation index zero point 0.6, and frequency is 30 hertz, right? And here the TSD is only 8.05%. TSD is only 8.05%, right? And current TSD you can see only 1.10%. 1.10%. So these are the result. I am skipping this. This I wish to show you. These are the hardware, and these are the simulation result for transient analysis. Right? You can see that voltage, that level operation from 2 to 5 level is changed at this instant. Immediately, the moment you change the modulation index, immediately it will change voltage level, and the current takes some time. To stabilize. This is the, you can see around 5 to 6 cycle it is taking. It is taking 5 to 6 cycle, and it is at no load, right? And similarly, when level changes from high to low, level changes from high to low, means 5 level to 2 level. These are the advantage of this 5 level inversion operation, that voltage and current harmonics are improved. Voltage and current harmonics are improved, right? And no requirement of clamping diode. No requirement of clamping diode, right? Now, in the same line of action, we go for 9 level inversion operation. 9 level inversion operation. You can see that the 2 level inverter, which was the basic building block of the open and winding based induction motor drive in this particular talk, the inversion operation is now 9 level and 4 module for this basic module, this basic module, this basic module. 4 basic module, which is 2 level inverters are used. And again, how this DC link voltages figure it out? Remember the formula. VDC1 by VDC by 2 is N2 minus 1 upon N2 into N minus 1. Depending upon that formula, this is figure out. And you can again notice VDC by 8, VDC by 8 means 2 VDC by 8, 2 VDC by 8 and 3 VDC by 8. So it is 3 plus 2, 5 VDC by 8, 5 plus 3 VDC by 8, so 8 VDC by 8 VDC by 8 is again VDC. Means DC link voltage is same because the power or the motor is same. Only what you do, you just open the neutral point of the induction motor. So the voltage level which it required remains same. Right? You get the advantage to have the bulky battery. For electric vehicle you can have small sizes battery, right? And a parallel charger can be used for this to charge them quickly, right? At the same time we can use the solar base rooftop of the vehicle. So that is also means use for charging of some battery, and meanwhile your inverter operation is reduced from 9 level to, let us say, 3 level, because both side 3 level inverter is there. So one battery, when you require less power, you can operate the motor at lower voltage level and this current level, and one battery during that period can be used as a means you keep on charging at that particular battery. That could be that possibility could be explored. Right? I'm just floating the idea. I'm just floating the idea. So here you can see your inverter A could have 0 voltage level or 3 VDC by 8 or 6 VDC by 8. Whereas your second inverter B could have 2 VDC by 8, 1 VDC by 8 and 0. So finally you will have minus 2 by 8 VDC, minus 1 by 8 VDC, 0, 1 by 8 VDC, 2 by 8 VDC, 3 by 8 VDC, 4 by 8 VDC, 5 by 8 VDC and 6 by 8 VDC. That you can have. Right? So you can have 9 level inversion operation. One important thing you can notice here, the inverter which is having higher DC link voltage, that switches less to have the all three level. You can see it is only switches once 0 to 3 VDC, then 6 VDC, whereas the inverter which is having less DC link voltage switches more rapidly. Here you can see 2 VDC by 8, 1 by 8 VDC, 1 by 8 VDC and 0. Means for each level it switches 3 times. For each level it switches 3 times. But no problem. Switching, more switching occur, that would have battery voltage less. Means lower switching losses would be there as compared to our that battery which is having DC link or higher DC link voltage, that is switching less. So switching losses are also reduced in this inverter, right? That ultimately improve the efficiency of the inverter. And this is the various levels L1 to L9, and various switching combinations are there for this to have this 9 level inversion operation. Okay. And here is the importance of this dual 2 level inverter. See, I can understand it is very difficult to grasp all these things within a means, small amount of time, that is only I think 90 minutes, right? Lot of research is involved in this. So many researchers are working on this. I'm just giving you one idea, right? You can have this idea. If you feel it is sounding to you, then just do research, do search, find some publication, read those papers. I have also given so many reference in the last, so you can go through them. And you, if you feel it is the topic or the field is related to your research area, your interest of area, then just go ahead. All right, that is the purpose of this type of short term course and FDP. We just float some idea in our particular domain, and if you also feel that is good for you, you just go with that, right? Now you can see the advantage. In neutral point clamp inverter, the requirement of DC source is VDC is in NPC as well as in FC, both required 1 1, whereas the proposed inverter does not require this much high voltage DC source. It is not, right? Similarly, the neutral point clamp, flying capacitor, and CHP. These are required 3 VDC by 8. No, these not required, but this required 2. Right? So a small DC source required. Whereas in comparison to the asymmetrical CHB, which required 3 DC source, the proposed inverter required only 2. Similarly for VDC 8 rating voltage source. If you talk about the IGBT of rating VDC by 8, your flying capacitor NPC and these are required 48. Just imagine. Whereas proposed required only 6. Another research quoted this that ACHB required 12, but this proposed inverter required only 6 as compared to this minimum quoted by this ACHB, asymmetrical CHB, where we take the DC link voltage in the power of 3, like 3, then 9, then 21, so on and so forth, right? Similarly, for VDC by 4, it required 6, like that. And if you see the clamping diode, NPC required 168 clamping diode, whereas proposed no requirement of this clamping diode. If you talk about the capacitor, you required 84 flying capacitor and 8 DC link capacitor required in NPC, whereas the proposed no requirement of these capacitor and all. Right? So these are the advantage of this dual 9 level inverter. And this is, you can see, this is the space phasor diagram. It is a little bit typical topic, and 217 redundant switching are available in this. But again, we use for this sinusoidal pulse width modulation, right? Along with injection of that our offset, which we have described earlier. And here you can see, uh, this it may be possible you start at the middle. You start at the middle, or you can start with the first triangular and you keep on increasing some offset, means you keep on moving this reference wave at the upper end and finally at the center. By applying this technique, the switching losses are reduced. How? Because the inverter operation here it operates in these levels, whereas here it operates in only two regions, L1 and L2. So the switching losses are reduced. The switching losses are reduced. So this give the advantage, this type of, and again you can find it from I will give you the reference. It is from Gopal Kumar sir paper, right? So from there you can have, and these are the hardware result, and this is for modulation index 0.16 and frequency is 8 Hz. The inverter operation in this case is 3 level. And one thing, the wonderful thing you can notice, the inverter 1 switching is 0. Means the
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 inverter
inverter
which is
which is
having
having
six
6
VDC by
VDC
8
by
means
8
3
means 3
VDC by
VDC
8
by
upper
8
side
upper
and 3
side and 3
VDC
VDC 8
lower side,
lower
like
side,
total
so total
VDC by
VDC
8
by
is
8
there,
is there,
and that
and
is
that is
not
not
switching at
switching
all,
at all,
or 3
or
level
3 level
inverter
inverter
operation. So
operation.
switching
So
losses
switching
will
losses will
reduce
reduce
drastically in this
drastically in
type
this
of
type of
inverter,
inverter,
right?
right?
And here
And
you
here
can
you can
see
see
the
that
TSD is
TSD is
40%.
40%.
If you
If you
remember,
remember,
although I know it
although
is
I know
very
it is very
difficult,
difficult
because
because
this may
this
not be
may
your
not be your
area of
area of
interest.
interest.
Anyhow,
Anyhow,
if you
if
remember,
you
for 3
remember,
level
for
inverter
3 level
operation,
inverter
when
operation,
modulation
when
index
modulation
was
index
zero point
was zero point
0.2,
0.2,
the
the
TSD was
TSD was
something around
something around
132.
132.
Whereas here
Whereas
the
here the
modulation index
modulation
is
index
still
is
low.
still low.
That means
That means
0.16,
0.16.
but
But
the TSD
the
is
TSD is
40.65%,
40.65%.
right?
Right?
That you can
That you
notice.
can notice.
TSD is
TSD
very
is
very
very,
less,
very less.
and
And
it is quite
it is quite
obvious,
obvious
because now
because
our
now our
inverter is
inverter is
9 level
9
inverter.
level inverter.
Our
Our
inverter is
inverter is
9 level
9 level
inverter,
inverter.
right?
Right?
And
And
similarly,
similarly,
these are the
these are the
simulation
simulation
results,
results.
and again
And
this is
again,
for
this is for
modulation index
modulation
point
index
8,
point 0.8.
and you can
And you
see
can see
the TSD
the
is now
TSD is
reduced
now
to
reduced to
6.10%,
6.10%, and the
6.10%, and
dominant
the
harmonic
harmonic
is
is
order
order
of
of 142,
142,
somewhere around
somewhere around
142,
142.
right?
Right?
Now,
Now,
similarly,
similarly,
this is for
this is for
modulation index
modulation
point
index point
36. This is
36.
for
This is for
modulation index
modulation
of
index of
0.36, and
0.36, and
frequency is
frequency is
18 hertz.
18 hertz.
Inverter is turned
Inverter is
out to
turned
the
out to the
this
this
5 level
five
of
level mode of
operation.
operation.
This is turned
This is
out to
turned
the
out to the
5 level
5
mode
level
of
mode of
operation,
operation.
right?
Right?
And the
And the
TSD
TSD
is
is
5.58%,
5.58%,
and the
and
current
the
TSD
current
is
TSD is
0.47%.
0.47%.
Just see
Just
the
see the
means
means
the
the
quality
quality
which is
which is
improved.
improved.
Hmm? Now,
Now,
this is
this is
for
for
modulation index
modulation
point
index
four
point
two,
four two,
modulation index
modulation
point
index
four
point
two,
four two,
and you can
and you
see
can see
for
for
this
this
TSD is
TSD is
3.58%.
3.58%.
TSD is
TSD is
3.58%,
3.58%.
right?
Right?
So that
So
is the
that is the
advantage of
advantage of
this.
this.
Now
Now
further
further
moving ahead,
moving ahead,
just a
just
minute.
a minute.
Sometime it
Sometime it
happen in
happen in
tablet.
tablet.
Okay.
Okay.
And now
And now
for
for
frequency
frequency
26 hertz
26
and
hertz and
modulation
modulation
index is
index is
0.52,
0.52.
inverter is
Inverter
turned
is
out to
turned
the
out to the
7-level
7-level
inversion mode.
inversion mode.
7-level
7-level
inversion mode,
inversion mode,
and you can
and you can
see the
see
TSD
that
is
TSD is
3.20%.
3.20%.
TSD is
TSD is
3.20%,
3.20%.
right?
Right?
Similarly,
Similarly,
for
for
modulation
modulation
index point
index point
0.8,
0.8,
frequency is
frequency is
40 hertz,
40 hertz,
and
and
TSD is
TSD is
very very
very,
less,
very less.
only
Only
2.27%.
2.27%.
2.27%,
2.27%.
right?
Right?
So
So
this is the
this is the
advantage of
advantage of
this 9
this
level
9-level
inversion
inversion
operation. Your
operation. Your
induction
induction
motor will
motor
feel
will
like
feel
it is
like it is
operated as
operated as
sinusoidal
sinusoidal
supply.
supply.
TSD is
TSD is
2.2,
2.2.
right?
Right?
Very very
Very,
least,
very least,
closest to
closest to
sinusoidal
sinusoidal wave.
wave, right?
Right?
And this is the
And this is the
transient
transient
operation. You can
operation. You can
notice
notice
in transient
transient
operation,
operation.
this is
This is
changes from
changes
2
from
level
2
to
level
9
to
level.
9 level.
Voltage
Voltage
again,
again,
even if for
even if
9
for
level
9 level
inversion
inversion
operation,
operation,
the
the
changeover from
changeover
voltage
from
level
voltage
2
level
level
2
to
level
9
to
level
9
is
level is
immediately.
immediately.
Immediately it
Immediately it
changes from
changes
2
from
level
2
to
level to
9 level,
9 level.
right?
Right?
But
But
stabilize the
step like the
current,
current
current takes
current
few
take few
cycle,
cycle.
current takes few
Current take few
cycle
cycle
to
to
again
again
retain its
retain
value,
its value,
you
or
can
the you
say
can
to
say
obtain
to
its
obtain
steady
its
state
steady state
stability.
stability.
It takes
It
few
takes
value,
few value,
few
few
cycle,
cycles
and
and
come to the
come to the
steady state.
steady state.
These are the
These are the
hardware result
hardware
and
result
these are
and
the
these are the
simulated one.
simulated one.
You can
You
see
can
there
see
is
there
one
is
to
one
one
to one
correspondence
correspondence
between
between
hardware and
hardware and
simulation.
simulation.
Whenever
Whenever
we
we
design
design
something,
something,
we
we
simulate
simulate
something,
something,
we
we
must
must
validate
validate
on
on
hardware.
hardware.
Then only
Then
it's
only it's
worthy and you
worthy
get
and
the
you get the
publication.
publication.
Otherwise, it is
Otherwise, it
very
is very
difficult to
difficult to
publish without
publish without
hardware
hardware
implementation of
implementation of
anything,
anything,
right? In a
right?
good
In a
journal.
good journal.
So you
So
must
you
think
must think
about
about
this
this
to
to
validate your
validate your
results
results
experimentally.
experimentally.
And these
And
are
these
the
are the
um, transient
transient
state
state
analysis from
analysis
higher
from
to
higher to
lower
lower
level of
level of
operation. You
operation.
can
You
see
can see
inverter was
inverter was
operated up to
operated
this
up to
point
this point
at 9
at
level
9 level
inversion
inversion
operation, and
operation, and
immediately it is
immediately
turned
it is
into
turned into
2 level
2 level
inversion
inversion
operation.
operation.
Immediately it is
Immediately it
turned
is
out to
turned
be
out to be
2 level
2 level
inversion
inversion
operation,
operation,
right?
right?
Okay.
Okay.
So
So
this is the
this is the
summary for
summary
this
for
9
this
level
9 level
inversion
inversion
operation.
operation.
As you
As you
notice
notice
that
that
as the
as the
reference
reference
speed or
speed or
modulation
modulation
index is
index is
increases,
increases,
our
our
inverter
inverter
operation or
operation or
inverter
inverter
output is
output is
become
become
smoother and
smoother and
smoother, right?
right,
Means it
means it
approaches towards
approaches towards
sinusoidal.
sinusoidal.
It
It
approaches towards
approaches towards
sinusoidal,
sinusoidal,
right?
right?
And
And
another
another
important
important
aspect you can
aspect you can
notice
notice
that
that
the
the
inverter which is
inverter which
having
is
higher
having
DC
higher
link
DC link
voltage
voltage
that
that
operates
operates
less,
less,
means the
means
switching
the switching
losses
losses
less
less
in the
in the
inversion, or
inversion, or
the
the
switching
switching
is
is
less, or
less, or
frequent switching
frequent
is
switching
less
is less
in the
in the
inverter which is
inverter which
having
is
higher
having
DC
higher
link
DC link
voltage.
voltage.
So
So
of course
of
the
course
switching
the switching
losses
losses
reduces,
reduces,
right?
right?
And
And
the third
the third
advantage which I
advantage
have
which I have
already told
already
you,
told
that
you,
you
that
can
you
place
can
the
place the
three reference
three
wave
reference
at the
wave at
middle
the
of
middle of the
the 8
eight
level shifted
level
triangular
shifted triangular,
or
or
the lower
the
one.
lower one.
If you
If you
place at
place at
lower
lower
triangular region
triangular region
and you
and
keep
you
on
keep on
gradually
gradually
increasing
increasing
the
the
voltage,
voltage,
that
that
half
the
of the
half of the
triangular,
triangular,
whenever that
whenever that
particular level
particular level
cross,
cross,
you will
you will
find
find
it
it
that
that
this
this
strategy
strategy
will reduce
will
the
reduce the
switching losses,
switching losses,
because
because
at lower
at
lower
lower
speed
speed
the
the
inverter
inverter
operate which is
operate which
having
is
less
having
DC
less
link
DC link
voltage,
voltage,
and
and
switching occur in
switching
the
occur in
inverter
the
which is
inverter
having
which
less
is
DC
having
link
less
voltage,
DC link
so
voltage,
switching
so
losses
switching
are
losses are
reduced
reduced
if you
if you
adopt this
adopt this
control
control
strategy.
strategy.
Now,
Now,
as of now,
as
we
of
have
now, we have
seen that
seen
9
that
level
9
inversion
level inversion
operation
operation
give the
give the
wonderful
wonderful
performance.
performance.
The only
The only
drawback is
drawback
it
is it
required
required
4
four
isolated DC
isolated
supply.
DC supply.
However,
However,
we have
we have
seen
seen key
since
since
this time is
this
for
time is
renewable
for
energy,
renewable
we have
energy, we have
distributed generation
distributed
system,
generation
we can
system,
have
we can
solar,
have
we can
solar,
have
we can have
wind-based energy,
wind-based
this and
energy, this
that,
and that,
and it is
and
very
it is very
means easy.
means easy.
You can
You
have
can have
several sources
several
at a
sources
time
at a
if
time
small
in
values.
small
For
values.
example,
For
the
example,
solar,
the
if we
solar,
talk
if we
about the
talk about
solar,
the solar,
there is no
there is no
problem to have
problem to have
multiple
multiple
sources,
sources,
because
because
the
the
solar small
solar small
cells are
cells
used,
are
and
used,
you can
and you can
club those
club
cells
those
to
cells
make
to
the
make
small
the small
batteries,
batteries,
right? But
right? But
still
still,
there is a
there is a
scope
scope
to reduce
to
the
reduce the
DC link
DC link
battery
battery
requirement,
requirement,
isolated DC
isolated DC
supply
supply
requirement. For
requirement.
that,
For that,
another
another
topology
topology
I am going to
I'm
show
going to
you,
show you,
which is
which is
flying
flying
capacitor based
capacitor based
topology.
topology.
Here only
Here
two
only
DC
two
link
DC link
are used.
are used.
Only two
Only
DC
two DC
links are
links
used
are
of
used of
voltage level
voltage level
VDC by
VDC by
2, of voltage
of
level
voltage level
VDC by
VDC by
2.
2.
One side
One
of the
side of the
inverter is fed,
inverter is fed,
one side of
one
the
side of the
this
this
open and winding
open and
induction
winding
motor is
induction
fed
motor is
by
fed by
5 level
5 level
inverter,
inverter.
and other is
Another
fed
is
by
fed
2
by
level
2 level
inverter, and this
inverter. And
5
this
level
five
is
level is
obtained by
obtained by
using
using
these
these
flying
flying
capacitor.
capacitor.
These 5
These
levels
five
are
levels are
obtained by
obtained by
using
using
these
these
flying
flying
capacitor,
capacitor,
right?
right?
So
So
the
the
level
level which
we
we
have
have
in this
in this
particular
particular
uh, configuration
configuration
are
are
minus 5
minus 5
VDC by
VDC
8
by 8
minus
minus
VDC by 2,
VDC by 2,
or you can say
or you can
minus
say
4
minus
VDC by
4
8,
VDC by 8,
because we keep
because
on
we keep on
decreasing
decreasing
VDC by
VDC
8
by 8
turn,
turn,
right?
right?
So it would
So
be
it would be
minus 4
minus 4
VDC by
VDC
8,
by 8,
then we would
then
have
we would
3
have 3
VDC by
VDC
8,
by 8,
then we
then
have
we have
this
this
4 VDC
4 VDC
by 8, sorry,
by 8,
2
sorry,
VDC by
2
8,
VDC by 8,
then we have
then we have
like this,
like
minus
this,
5
minus
VDC
5
by 8,
VDC by 8,
minus 4
minus
VDC
4
by 8,
VDC by
minus 3
8, minus
VDC
3
by 8, and
VDC by
minus 2
8, and minus
VDC
2
by 8.
VDC by 8.
So these are
So
the
these are the
phase voltage.
phase voltage.
But
But
since
since
redundancy is not
redundancy is not
available
available
in this
in
level,
this
that is
level,
minus
that is
5
minus
VDC
5
by 8,
VDC by 8,
so we have
so
not used. We have
we
not
have
used for
not used for
generation of
generation
level,
of level,
and we
and
have
we have
these
these
level
level
of
of
operation
operation
for
for
generation of
generation of
level.
level.
These are
These are
like
like
this.
this.
These are like
These are
this,
like this,
right?
right?
We don't
We
use
don't
plus
use
VDC
plus
5
VDC
VDC
5
by
VDC
8,
by
and
8,
we
and
don't
we
use
don't use
minus
minus
5
5
VDC by 8.
VDC by 8.
Why? Because
Why? Because
redundancy is not
redundancy is
there.
not there.
Another thing,
Another thing,
see,
see,
redundancy means,
redundancy means,
see, the
see, the
main
main
focus or the
focus
main
or the
key
main
point
key
of this
point of this
topology is
topology
you
is
have to
you
have
have to have
maintained
maintained
the
the
capacitor
capacitor
voltage
voltage
constant at
constant at
VDC by 8
VDC by
level.
8 level.
Otherwise,
Otherwise,
this
this
topology will not
topology will not
operate. It will
operate.
not
It
give
will
you
not
the
give you the
desired
desired
result.
result.
So the
So
main
the
task
main
is
task is
this
this
capacitor voltage
capacitor
has to
voltage
be
has to be
maintained
maintained
at
at
constant
constant
level,
level,
right?
right?
To
To
have
have
these
these
voltage
voltage
constant,
constant,
we
we
have
have
let
in
us
let us
take this
take this
example.
example.
You can
You
have
can have
these are
these are
CA1 and
CA1 and
CA2. There
CA2.
are two
There are two
capacitor per
capacitor
phase.
per phase.
You can
You
see,
can see
if you
if you
operate
operate
level
level
6 means
6
you will
means
have
you will have
VDC by 8
VDC by 8
voltage.
voltage.
Your
Your
capacitor
capacitor
CA1 is
CA1
not
is not
affected,
affected.
means it is
Means it is
bypass.
bypass.
Whereas
Whereas
CA2 is
CA2 is
charged
charged
if you
if you
use this
use
switching.
this switching.
In another
In
switching,
another
voltage
switching,
level
voltage
remains
level
same,
remains same. Minded,
voltage level
voltage
remains
level remains
same,
same,
and your
and
first
your first
capacitor is
capacitor
that is
is that is
CA1 is get
CA1 is get
charged,
charged.
whereas
Whereas
another one
another one
is
is
discharged.
discharged.
If you take
If you
this,
take this,
voltage level
voltage level
again
same,
same, but this
but this
capacitor
capacitor
discharged,
discharged,
and this is
and this is
also
also
discharged,
discharged,
and here
and
it is
here
charged.
it is
So
charged.
you will
So you will
have
have
both type
both
of
type of
possibility,
possibility.
means your
Means your
capacitor get
capacitor get
charged, your
charged, your
capacitor get
capacitor get
discharged.
discharged.
What you
What
have
you
to
have
do,
to
you
do, you
keep on
keep on
measuring the
measuring the
capacitor
capacitor
voltage
voltage
CA1 and
CA1 and
CA2
CA2
all the
all
time.
the time.
You
You
keep on
keep
measuring
on measuring
once, and it
once,
has
and
to
it
be
has to be
operated in the
operated in the
status mode.
status mode.
Once
Once
capacitor
capacitor
voltage is
voltage is
crossing the
crossing the
upper limit,
upper limit,
you
you
have to
have to
operate the
operate the
switches
switches
to in
to
such
in
a
such
way
a way
that this
that this
capacitor
capacitor
get
get
discharged.
discharged.
And when
And
it
when
touches
it
the
touches
lower
the lower
limit,
limit,
you have to
you have to
operate the
operate the
switches
switches
so that this
so that this
capacitor get
capacitor get
charged.
charged.
In that
In
way, you
that way,
will
you will
maintain the
maintain the
capacitor
capacitor
voltage
voltage
at
at
particular level
particular
with
level with
certain
certain
variation.
variation.
For
For
example,
example, in the present
I
case,
have
I have
taken the
taken the this
voltage
voltage
variation of
variation of
plus minus
plus
2,
minus 2.
means you
Means you
required
required
50 volt,
50 volt,
so the
so the
voltage is going
voltage is
from
going from
48 to
48 to
52,
52.
means
Means
minus
minus plus
to
minus to
50 plus
50
to
plus to
52,
52,
50 minus
50
to
minus to
48,
48.
in that
In
way.
that way.
So
So
if you
if you
operate in
operate
that
in
way,
that way,
you can
you can
maintain the
maintain
voltage
the
level
voltage level
constant. Here you
constant.
can
Here you
see,
can see,
for
for
example,
example,
to
to
have
have
this
this
where no
where no
capacitor
capacitor
is
is affected
because current
because
is
current
not
is
passing
not
through
passing
the
through the
capacitor,
capacitor,
not passing
not
through
passing
the
through the
capacitor. So
capacitor. So
no
no
uh, disturbance
disturbance
in
in the
the capacitor.
capacitor.
Look at this.
Look at this.
Current is
Current
not
is
passing
not
through
passing
the
through the
capacitor.
capacitor.
So
So
capacitor
capacitor
voltage
voltage
remain
remain constant.
right?
Right?
Just
Just a minute.
similarly,
Similarly,
whenever
whenever
the
the current go like this,
it will
it
get
will
charged,
get charged,
and
and
whenever
whenever
current
current
go
go
like
like
this,
this,
it will
it
get
will get
discharged.
discharged.
So you
So
have to
you have
figure
to
out
figure out
the
the
particular
particular
switching
switching
instant. That is
instant.
why
That is
there
why
is a
there is a
redundancy in the
redundancy in
table.
the
You can
table. You
see
can
there is
see
a
there
huge
is a huge
redundancy
redundancy
for
for
L7.
L7.
L7 means
L7 means
particular voltage
particular
level
voltage
of
level
plus
of plus
VDC going
VDC
4.
going 4.
You have
You have
several
several
combinations of
combinations of
switches.
switches.
In one
In one
combination it may
combination, it
get
may get
charged,
charged.
with
With
another
another
combination it may
combination,
get
it may get
discharged,
discharged,
whereas
whereas
another
another
capacitor not
capacitor not
affected,
affected.
so on and
So
so
on and
forth.
so forth.
Right, so that
Right?
thing
So
you
that
should
thing you
keep in
should
mind
keep in mind
to design
to
such
design
type
such
of
type of
inverter.
inverter.
And now
And now,
if you
if you
compare this
compare this
topology
topology
with
with
the
the
available
available
well
well
established
established
topology, you will
topology, you will
find
find
there is a
there is a
drastically
drastically
reduction in the
reduction in the
component
component
of the
of the
inverter.
inverter.
You can
You
see
can see
VDC
VDC
source
source
requirement
requirement
VDC.
VDC.
No, we don't
No, we
require
don't
any
require
VDC
any
voltage
VDC
source.
voltage
If
source.
you talk
If you
about
talk
3
about
VDC
3
by
VDC
8,
by
no,
8, no,
as it was
as it
required
was
in the
required in
previous
the
one.
previous one.
No, it is
No,
not
it is
required.
not required.
VDC by 2,
VDC
of
by 2,
course,
of
two
course,
sources
two
are
sources
required.
are required.
And if you
And
talk
if you
about the
talk about the
IGBT
IGBT
requirement, you just
requirement, you
see
just see
48.
48.
You
You
required
required
48
48
IGBT of
IGBT
rating
of
VDC
rating
by
VDC
8
by 8
for
for
conventional
conventional
inverter,
inverter,
whereas
whereas
present it
present it
required only
required
12.
only 12.
It required
It
only
required
12.
only 12.
Of course,
Of course,
there is
there is
some
some
advantage and some
advantage and some
disadvantages are
disadvantages
there.
are there.
There you
There
required
you required
48, here you
48, here
require
you required
12.
12.
At the same
At the
time,
same time,
you require
you require
different rating
different rating
IGBT,
IGBT,
right?
right?
So spare
So spare
management is a little
management is a
bit
little bit
difficult,
difficult,
right?
right?
Because you
Because you
required
required
12
12
IGBT of
IGBT of
VDC by 8
VDC by
rating,
8 rating,
12
12
IGBT of
IGBT of
VDC by
VDC
4
by
rating,
4 rating,
and
and 12,
6
6
IGBT of
IGBT of
VDC by 2
VDC by
rating.
2 rating.
So you
So you
require
require
different rating
different rating
IGBT. So
IGBT.
that
So
is the
that is the
means
means
disadvantage you can
disadvantage, you
say,
can say,
or
or
constraint you can
constraint,
say,
you can
right?
say, right?
And this is
And
the
this is the
this control
this control
strategy
strategy
for
for
this
this
particular
particular
configuration.
configuration.
The
The
reference
reference
speed
speed,
user will
user
give,
will
see
give,
in
see in
industry what
industry
happened,
what
there is
happened.
a
There is
drive
a drive,
and
and
operator
operator
will give
will
the
give
speed
the
only
speed
that.
only that.
Now being
Now
an
being an
engineer, you have
engineer,
to
you have
design
to
a drive
design
in
a
such
drive
a
in
way
such a way
that
that
from that
from that
particular
particular
speed it will
speed it will
draw the
draw the
voltage,
voltage,
frequency, everything,
frequency,
whatever
everything,
the
whatever the
required
required
parameter, it will
parameter, it will
conclude
conclude
that it
that
will
it will
get the
get
inference
the
from that
inference from that
particular
particular
reference
reference
speed
speed
and
and
operate your
operate
drive
your
in such
drive in
a
such a
fashion
fashion
that your
that
speed
your
torque
speed torque
characteristic
characteristic,
which is
which is
required
required,
is
is
provided by your
provided by
drive.
your drive.
So what you
So
have to
what you
do,
have to do,
you get the
you get the
reference speed
reference
from the
speed from
user
the user
or the
or the
operator
operator
and operate
and
in the
operate in the
constant flux
constant
mode,
flux mode.
so you get
So
the
you get the
voltage and
voltage and
frequency.
frequency.
Once you have
Once you
voltage
have
and
voltage and
frequency, you have to
frequency, you have
generate
to
the
generate
three
the
reference
three
wave.
reference wave.
Once you have
Once you
three
have three
reference wave,
reference wave,
means all
means
those
all those
offset and
offset and
everything you have
everything you
added
have added
that
that
is
is
generated.
generated,
And
and
now you
now
have
you
one
have one
lookup table.
lookup table.
Why lookup
Why
table is
lookup table
required?
is
Because
required?
you
Because
keep
you
on
keep on
measuring the
measuring the
voltage
voltage
level of
level of
all
all
capacitor. You
capacitor. You
require
require
measurement of
measurement
6
of 6
capacitor because
capacitor
each
because
phase
each
is
phase
having
is having
2
two
capacitor per
capacitor
phase.
per
So
phase.
total
So
6
total 6
capacitors are
capacitors
required.
are required.
At the
At
same
the
time,
same time,
you must
you
measure
must
the
measure the
current,
current,
phase current,
phase current,
because the
because the
direction of
direction
current
of
is
current
also
is also
important.
important.
Direction of
Direction
current
of
is
current is
also
also
important,
important,
whether it is
whether it is
charging
charging
or
or
discharging
discharging current,
current, right?
right?
So that is
So that
also
is also
required.
required.
And then
And then
from lookup
from
table
lookup
it will
table, it
check
will check
what is the
what is the
direction of
direction
current,
of current,
what is the
what is the
status of
status of
capacitor.
capacitor.
If the
If the
direction of
direction
current
of
is the
current is the
charging mode
charging mode
and the
and the
capacitor
capacitor
voltage is
voltage is
overcharged, how it
overcharged,
should
how
be
it should be
operated to get it
operated to get it
discharged,
discharged,
that it will
that
take
it will
care of
take care of
that lookup
that
table,
lookup
and the
table, and
switching
the
is
switching is
generated. And
generated.
these
And
switchings
these
are
switchings are
fed to the
fed to the
IGBTs to
IGBTs
get the
to get the
desired
desired
level,
level,
right?
right?
And again,
And
what I
again,
was telling
what I
you,
was telling you,
that
that
hysteresis.
hysteresis.
This is the
This is the
capacitor. How you
capacitor.
decide the
How you
capacitor?
decide
It is
the
decide
capacitor?
on the
It is
basis of
decide on the basis of
this voltage
this
variation. How
voltage
much
variation.
voltage
How much voltage
variation you can afford. That is, in particular case, it is plus minus 2, so the voltage variation is plus, you can say delta is 4 volt. right? Minus 2 to
right?
plus 2.
Minus 2 to plus 2.
And TS is the
And
sample
TS is
time.
the sample time.
Each and
Each
these
and these
parameters are
parameters are
measured,
measured,
calculated, and
calculated,
generated
and generated
pulses in
pulses
first
in
sample
first
time.
sample time.
Sample time which you
Sample time
define in
which
your
you define
simulation.
in your simulation.
Even though it is a
Even
real
though
time
it is a real
simulation,
time simulation,
but
but
it has certain
it
time,
has certain
certain
time,
sample
certain
time. For
sample time.
that
For
sample
that
time,
sample
you
time,
have to
you have to
you have to
you
select,
have to
you
select,
have to choose
you have
sample
to
time
choose
so
sample
wisely
time so
that
wisely
all the
that
calculation
all the
must be done
calculation must be
in
done
that particular
in that
sample time,
particular sample time,
right? On the
right?
basis of
On the
that,
basis of
we
that,
calculate the
we calculate
capacitor
the capacitor
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 rating.
rating.
What should be the
What
rating
should
of
be the rating of
capacitor, right?
capacitor, right?
Okay, now
Okay,
come to the
now come
result.
to the result.
And see, of
And
course,
see, of
it's a
course,
911
it's a
inverter
911
operation. You
inverter
will get the
operation. You will get
almost
the
same result
almost same
which
result
you have
which
in
you
the
have in the
previous
previous
inverter.
inverter.
But
But
here you also
here you
have the
also have the
capacitor voltage.
capacitor
You
voltage.
can
You
see
can see
there
there
that the
that
capacitor
the
voltage
capacitor
is
voltage is
almost constant.
almost constant.
Capacitor voltage
Capacitor
is
voltage is
almost
almost
constant,
constant,
right?
right?
This is the
This is
TLC,
the
which of
TLC,
course
which
has
of
to be
course has
same
to
as
be
it
same as
in the
in
previous
the
case,
previous
no
case,
problem.
no problem.
And here
And
you can
here you
see
can see
I
I
required
required
that
that
VCA1 has to
VCA1
be
has to be
50 volt,
50 volt,
right?
right?
But
But
here it is
here it is
48. So
48.
no
So
problem.
no problem.
As I said,
As I said,
my delta
my
was
delta
plus
was
2 to
plus 2
minus
to
2. That
minus
means
2. That means
up to
up to
52 to
52 to
48, I don't
48,
have
I
any
don't have
problem.
any
And my
problem. And
voltage
my
rating is
voltage
within
rating is
that
within
limit.
that limit.
It was
It was
25 volt,
25
so
volt, so
25 plus 2,
25 plus 2,
27, and
27, and
25 minus 2,
25 minus 2,
23. So
23.
if
So
it is at
it is at
23, I don't
23,
have
I
any
don't have
problem.
any problem.
My
My
calculus, my
calculus,
everything
my
is
everything
working
is working
absolutely fine
absolutely
because
fine
the
because the
capacitor voltage
capacitor
is
voltage is
maintained
maintained
at that
at
particular
that
level
particular
which I
level which I
required.
required.
These are the
These are
hardware
the
result. You
hardware
can
result. You can
see.
see.
Just a minute.
Just a minute.
Sometime,
Sometime,
sometime
sometime
stick हो जाता है.
stick हो जाता
Okay,
है.
now just a
Okay,
minute.
now just a minute.
Okay.
Okay.
And now you can
And
see
now you
these
can
are the
see these are the
simulated result,
simulated
and
result and
the waveform,
waveform
the capacitor
the
voltage is
capacitor voltage is
absolutely constant,
absolutely
right?
constant, right?
I have also
I have
tested
also
the
tested
inverter
the
for
inverter for
this capacitor
this
balancing logic.
capacitor
I
balancing
hope
logic.
I
I
have
hope
included
I
that
have
result here
included that
also.
result here
These
also.
are the various
These are the
result
various
for
result
different
for
modulation
different
index.
modulation
And
index.
here you can
And here
see
you can see
this here
this here
at instant
at instant
this.
this.
The capacitor
The
voltage
capacitor
VCA1
voltage
logic is
VCA1
disabled.
logic is disabled.
Intentionally it was disabled.
Intentionally it was
Just to
disabled.
check
Just
what
to check
happened. You
what
can
happened.
see
You can
the
see
moment it is
the moment
disabled
it is
at this
disabled
instant,
at this
the
instant,
capacitor
the
voltage keeps
capacitor
on
voltage
increasing.
keeps on increasing.
The capacitor
The
voltage
capacitor voltage
VCA1 keeps on
VCA1
increasing.
keeps on increasing.
At instant
At
T2,
instant
it
T2,
is
it
again
is
enabled.
again enabled.
Very quickly it
Very
come to
quickly
the
it come to the
original value.
original value.
So
So
effectiveness of the
effectiveness of the
capacitor voltage,
capacitor
effectiveness of the
voltage,
capacitor voltage is also
effectiveness of the capacitor
checked
voltage
in
is
this
also
particular topology.
checked in this particular
Similarly for
topology.
VCA2, that means the
Similarly for
another capacitor
VCA2, that means the
which is
another
in that
capacitor,
particular H bridge,
which
if
is
you
in
remember the
that particular
topology,
H
although
bridge.
I
If
know
you
it is
remember the
very
topology, although I know it is
quickly
very
going things.
quickly going
Anyhow,
things.
so
Anyhow,
here you can see it
so
is disabled
here you
here,
can see
it
it is
keeps on
disabled here.
increasing.
It keeps on increasing.
And once again it is
And once
enabled at
again
instant
it is
T3,
enabled
it
at instant
comes
T3,
to its
it
original
comes
value
to its
very
original value
quickly.
very
And same
quickly.
thing is
And same thing
applied
is
on
applied
cross check in
on
the
cross
simulation.
check in the
And you can
simulation.
also
And you
notice
can also
the
notice
moment
the moment
this is
this
disabled.
is
Let
disabled.
me zoom this.
Let me zoom this.
Okay.
Okay.
See, you
See,
can,
you
I
can,
hope you can
I
notice
hope you can
there is
notice
slightly
there is
variation in
slightly
the
variation in the
output voltage.
output
It has to
voltage.
be
It has to
because
be
capacitor
because
voltage is
capacitor voltage is
increasing. Capacitor
increasing.
voltage is
Capacitor voltage is
increasing.
increasing.
It is increasing.
It is
So
increasing.
here you
So
can see
here you can see
voltages get disturbed
voltages get
and it
disturbed
keeps on
and it
increasing.
keeps on increasing.
Right? and
right?
once it is
And
again
once it is again
stabilized, it come
stabilized,
at the
it come at
same
the
level which it
same
was
level which it
earlier.
was
Right,
earlier.
so that type
Right?
of
So that
things
type of
are cross
things
checked
are
in this
cross checked in
particular
this particular
topology.
topology.
And
And
now the
now
advantage
the
is
advantage is
this: you
this:
will have
you will have
uh,
uh,
this
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 means the
means
9 level
the nine
inversion
level
which I
inversion
have
which
shown
I
you
have shown
in
you
the
in
this the four
the
topology,
four topology,
that was the four
that was the
topology,
four topology,
9 level
nine
inverter
level
operation.
inverter
So
operation.
in
So in
comparison to that,
comparison
we
to that,
required
we
only
required only
two
two
DC link
DC
voltage.
link voltage.
And these
And
are some
these are some
difference of
difference
in
of
fact my
in fact
paper
my paper
which you can
which you can
have
have
to cross
to
check,
cross
or
check,
means
or
if you are
means if you are
interested you can
interested, you
go
can
through
go
these
through these
references
references
and
and
get some
get some
knowledge, or
knowledge, or
means your query
your
answered
query answered
if you have.
if you have.
Right,
Right?
so
So
from
from
my side,
my side,
let me
let me
just
just
give me a second.
give me a second.
From my
From
side,
my side,
this is,
this is,
and
and
if you have any
if you
query
have any
you
query,
can ask.
you can
You
ask.
can also
You can also
check
check all these
means
means
material and
material
everything
and
at my
everything
YouTube
at my
channel,
YouTube channel,
which is
which is
at the rate Power
at the rate Power
Electronics by
Electronics
Dr.
by
Sanjeev sir.
Dr. Sanjeev sir.
It is
It
available.
is
If you wish,
available.
you
If
can
you
go
wish, you
through
can
this.
go through this.
Anyway, if you have
Anyway, if
any
you have
doubt,
any
any
doubt,
query,
any query,
please ask,
please ask.
because the
Because
time
the
allotted
time
to me
allotted to
was
me
up to
was up
5,
to 5,
and this
and
is
this is
4:53 already.
4:53 already.
So we have
So
still
we have
7
still
minutes,
7 minutes,
and if
and
coordinator
if
allow, we
coordinator
can
allow,
continue
we can
further.
continue further.
Yeah, thank you, sir. Thank you for your nice talk and enlighten the participants with your expertise and the deep research in the open end winding for electric vehicle applications, open end induction motor drives. So, dear participants, Sanjeev sir is experts in this domain. So, always feel free to contact him, whoever is working in this domain and who wants to work in this domain further, and always he will be happy to assist you, or he will be guide you in this domain of research. And we are really thankful to have Dr. Sanjeev sir here as an expert in our short term course. Thank you, sir. Thank you once again on behalf of all the coordinators and Department of Electrical Energy, Electrical Engineering, NIT Surat. Uh, we thank you.
Thank you, Sukant.
Thank you, Sukant.
Thank you for
Thank you
inviting
for
me for
inviting
such a
me for
wonderful
such a
FDP.
wonderful
I
FDP.
wish
I
great
wish
success of
great
your
success of
FDP this short
FDP
term
this
course,
short term course,
and expect
and
many more
expect
from
many
your
more
side.
from your side.
Yeah, dear participants, please feel free to ask if you have any queries. Yeah, I think, sir, we are good. Audience definitely will contact you in future. They will email you.
Definitely,
Okay.
definitely.
Yeah.
Definitely.
Thank you, sir. Thank you once again.
Thank you, Sukant.